bother us. So let me fire up our from Santa Barbara, it's Westmont College Mayterm. We're here as part of CS-030. We're in the basement of the hall today in Santa Barbara. It's a little bit rainy out. That means it's kind of the sidewalk. And we're trying to hold up under the pressure of the deluge, which is keeping the sidewalks wet. And this is part of a 5-week class. Today's lecture is scheduled for 2 hours. We are communicating live on Slack for those who have access to it on #broadcastquestions. And otherwise, shout out to our friends on YouTube who are following along. Some of whom are following along that we don't know. So those folks that are part of the 20-odd people that are following the class that aren't enrolled, welcome. Hope we can be of some service to you. All right, so getting started, let's just arrive, recognize that we're here, get our notifications in order, so make sure mine are off as well. Remember that we are here trying to learn something for a greater goal, not of just learning how to program, but for figuring out what we're going to do with those programs as well. And so one of the things that we've been doing is thinking through the role of how programs participate in regulations. We're talking about that, but actually, I want to not talk about that again today, but instead I want to just read a poem. This is a poem by one of our faculty, Paul Willis, whose work I'm a great fan of, and also a great fan of him as a person as well. One of the things that's neat about having people that are accomplished nearby is that the things that they write about and they experience are actually local to us, and so you might be part of it. So Dr. Willis wrote this poem about a sign that's right outside of our building. It is sign that you might recognize. It's a bus parking sign. And he took a look at that and wrote this poem. And what he wrote was a poem called Idling for 1 Minute Only. And I'll just start us off today by reading this. Here is a sign that surely reflects the Puritan heritage of our college. For though it is meant for the coaches that pull up to the curb, dispersing limbs of basketball players, who loiter at the back of the gym, I always think it applies to me, standing here in the new warmth of the winter sun, watching the first green tips of grass emerge from the dampness of the ground. Idling for 1 minute only. I think that's a fun poem because he's drawing attention to sort of the speed at which we run at, and the idea that we should only be allowed to idle for 1 minute, thinking about the world around us or thinking about what we're doing. Obviously, that's not what the sign is about. The sign is about parking and leaving your engines running. But it's a good reminder to think about spending time to be present, think about what you're doing, make sure you're doing the right thing, enjoy what you're doing as well. And I think it's cool that he sort of recognized that in the sign that was meant for something completely different. All right. So for our class, administrative-wise, paper exams are the return of the paper exams are still a little bit delayed. We're having a little bit of a glitch with the combination of Canvas and Proctor Free, which reminds me, James, before you take that test, I got to do one more thing to make it work. If you're following along, know that. Okay, we have a programming assignment due about Chapter 18 on Friday, and a quiz for Chapter 18 is due Friday as well. This week we're talking about Chapter 18 yesterday and today, and then we're going to talk about Chapter 13 Thursday and Friday. Next Monday we'll tackle the drone assignment and think about that a little bit, and then we'll spend some time looking at tree data structures next week before our final. And that's it for Mayterm. Fast. Any administrative questions? Good. All right. Then, from last time, what did we do? Well, we spent a little time explaining the rationale and implementation of generics. On the right, you see some code there, which is the implementation of a basic pair class in generics. We saw how what this allows us to do is to write code that's kind of agnostic to what reference you're working with, because we also talked in the last class about how references can be combined. We could have two variables that point to the same thing. And if you change what one is pointing to, you're also changing the same memory that the second one is pointing to. And so because we're just dealing with references to objects, and we don't even necessarily know what the objects are, just manipulating those references is all the work that some of these classes do. So when all you're doing is manipulating references and you're not paying attention to what they're pointing to, you can write it as a generic. And so this is an example of that. This generic pair has two references, something that's the first and something that's the second. And for the work that it does, which is just keeping them together, it doesn't have to know what the reference is pointing to, what the type of the reference is. So we talk about it generically as F and S, right? We're pointing to something of type F and pointing to something of type S. And what it is doesn't matter because we're just moving them around and keeping track of them. Lists are like that too. Linked lists and array lists are just keeping track of something. And so what they're keeping track of kind of is secondary to the way in which it's maintaining an order generally. So we talked about some of that motivation, how that enables us to have strong type checking, but also enables us to be flexible with our code and to write code one time rather than having to duplicate this code, for example, for all the different kinds of pairs of types we might want to put there. Because we could also write this code where we instantiated F and S with specific reference types like string or double or integer, or your own class identity that you might write. And then we spent some time implementing, taking our linked lists and then transforming it into a generic version of linked lists. So that's some of the things that we started with last time. So what I would like to start with today is to finish that work that we did, which was implementing generics and linked lists. But we also have to go back and we have to implement generics in our array lists as well to prove that it can be done. So we'll start there, and then we're going to do some other work with Eclipse and Saros today, trying to work through how we get generics to work in our own code. So let's go ahead and try and set up our array list with generics. Now, when we do this, we're going to run into this problem. I said in the introduction to generics that generics and arrays don't mix, and more generally, generics and primitive types don't mix. And the problem is that our array lists as an implementation had as a fundamental piece of data that was working with was an array. And so we're going to have this problem where we can't actually make an array of a generic type. So we're going to have to manipulate the inheritance hierarchy a little bit in order to make it work. And we're going to have to do some typecasting. Now, the problem with that is that typecasting was exactly the problem that generics was supposed to avoid. We don't like doing typecasting, which means forcing Eclipse to think of a reference as a particular type, regardless of what the code seems to indicate, because that opens us up to these problems that our off-duty Santa from last lecture might run into, where he's working with the code after it's been deployed, you typecast something, and it turns out that the object itself wasn't that type. So usually, this kind of work isn't type safe. We don't like typecasting things into other types that they're not hard-coded into in the language. But because in our array list, we're the gatekeeper for what goes into our array, and we're the gatekeeper for what comes out of the array, we're going to be able to make sure that only our generic type gets put into the array, even though we can't do generics all the way, because we're implementing. Why do arrays not work? Because arrays, generics require some support from the objects that are being used as the type. So when you make an array list of type string, generics need some of the support. I don't know what to say. How do I put this? In order for the underlying mechanisms that are used in order to implement generics in the compiler, it needs the type itself to have some support for things like reflection, for inheritance, some other properties that come with reference type are necessary in order to make generics work, to make like the machinery of Java make it work. And primitive types don't have any of that support. So because you can't, for example, call a method on a primitive type, and because there's something called reflection, primitive types can't reflect on themselves, which means they don't know that, this is a little bit weird, but types like string have the ability to reason about themselves, knowing that they are string classes. It's like a metacognition. Gosh, wow, where'd this go? There's a whole set of properties with some references called reflection. And reflection means that the code can reason about itself knowing that it's code. And integers don't have, or ints don't have that ability. And arrays don't have that ability because they're inherited from languages that didn't support that, like C, principally. So your question was, why don't they play well together? They don't play well together because the type itself doesn't have enough support. Why didn't they update arrays so that they could support? Oh, well, I would say that the primitive type of array has been upgraded to be an array list. So an array list can support, an array list, you can't put primitive types into an array list. So let me just clarify what I'm talking about here. Saying stuff. So we're gonna look at the array list in a second, but here's a blank piece of code. I missed again. Okay, so here's an example of a class, and if we just create some space for us to do some work by creating a main function. Fingers, wake up. All right, so here's an example of a primitive type, an int. Here's another example of a primitive type, double. Here's another example of a primitive type, which is an array. So what I've declared is a primitive type variable I, which is an integer, primitive type D, which is a double, and a primitive array, which holds. Now, if I wanted to do that in the more recent version of the way that we think about object-oriented programming, I would say integer I, double DD, and then array list integer. And I could initialize it. So I want to implement the Java version of ArrayList for demonstration here. All right, so here's some things that you can't do. For example, you can't say wow, look at that, you can do that. You can, okay, so fair enough. You can do that, but you can't do it with generics. So you're not going to be able to put a generic type in there, which is what we're about to try and do. Okay, so that's a mistake. You can make an array of reference types, but you can't do it the other way around. You can't do that. It kind of makes sense because the array list, the generic type, needs the features of the object-oriented types, but the array can just be an array of references. Okay, so they don't play well together. So let me share this project with you, and what we're going to do is we're going to take what we did last time. So I copied over the code from last class where we had updated our linked lists, and you can see that our array lists are failing. That's because we changed the interface to be a generic interface, and we haven't updated our array list to match that interface. So let's start off by sharing the project with you guys, assuming I'm connected. All right, let's. Boaz, are you online? All right, here we go. All right, so we're sharing the project across you guys. All right, so now our goal here is to take array list, got some color coding from the testing, and we need to update it so that it is going to be supporting of a generic type. Boaz is online. Hello, Boaz. Feeling sick. Okay. So we want to implement this with a generic type. And so what we're going to do is we're going to first just declare that our object uses a generic type by putting it in the definition of the class. And we have something going wrong there. Oh, okay. So it just wants me to implement the appropriate things. Okay, so now here's the thing that we were ultimately trying to do. We were ultimately trying to support any kind of object in this array that we wanted. So Tim, this was to your point. String is actually an object, and so we're able to create an array of it. I misspoke earlier. But what we can't do is we can't put a generic type in there, which is what we really want to be able to do. We want to be able to create an array of generic types. But if you hover over that, you can see it's not supported, cannot create a generic array of L. So this is where we're going to have to create a little hack. What we're going to do is we're going to create an array of objects. And as you know, objects are the superclass of all reference types. And so we're going to store some unknown reference in there. And that's what we're actually going to be storing are things of type L. We know because everything that is in a generic must be an object of some kind, and so it's descended from the object class. So we know we can store them in this array, but we're going to lose all the properties of the L along the way. We're going to have to work with that. Let's for a second close our list iterator and not deal with that, and instead let's work through our add method. So in our add method, what we want to do is instead of adding a generic thing of type string, we want to add something of type L. That's our generic type. And as we come down here, everything works fine because when we end up putting an L into our contents contain object types. And so our what is going to be converted into an object type along the way. We're going to lose the properties of whatever type L was, but we're going to be able to store it already. Okay, similarly, when we remove something, we actually want to return the object that we remove. And we know that should be of type L because that's what we're storing in an array. And we know that the thing that we're returning is going to be of type L as well. So that's going to make that work. But here's where we run into this problem. Our array, our implementation array, does not contain a bunch of L's. It contains a bunch of objects. And so in order to return something that has the properties of L, so the compiler allows us to do the kinds of method calls and reference the instance variables that might come with L, we have to typecast it to an L here, forcing the compiler to say that this is from now on should be treated as an L. And you can see we get the warning, we have a type safety warning. We have an unchecked cast from object to L, which means the compiler's forcing this reference to be treated as an L, but there's no guarantee that it actually is an L according to the compiler. Now we actually know that it is an L because the only things that we're going to put in there are going to be in our add method. And our add method insists that we receive an L. So we're doing the work of type checking here because we're ensuring that the only thing that goes into our contents are L. Because here in our add method, what are we putting in? We're putting in L's. And what are we taking out? We're taking out L's. But the compiler's not doing the work for us. We're having to make sure that that's consistent. So that's what generics do for us, but because we chose an implementation that's based on an array, we can't actually pull that off. So get as well is going to return an L, and we're going to have to typecast what we return to be an L here. Again, get a type safety warning. And then the list iterator has got to be a list iterator that iterates over an array of things of type. So let's see. So now if we go back up to our list iterator, we know that our list iterator has to have the following methods, has next. When we walk over something, we want to return something of type L, and so we need to typecast the element we're walking over to be of type L. When we add something, we know we want it to be of type L. This is where we ensure that the things that we're adding are the correct type. We call ourselves, and so we make sure we never add anything that's not of type L. When we remove something with the iterator, the thing we're going to return is going to be of type L, and because remove returns something of type L, we don't have to typecast that because remove itself did typecasting already. And then when we want to set something, well, we want to set the data that's present. It's got to be of type L, and the thing that we're overwriting, that we're returning, is going to be of type L as well, but we need to cast that to be of type L. And hang on one second. Okay, what's the difference between typecasting and initializing it with a type? If you declare your array to be holding objects, you can put anything that descends from object into that array. So you can put a string, capital D double, or capital I integer, or a generic type in there. And the compiler will say, well, these are all descendants of objects, so that's okay. You can put any of them you want into the array. But when you take something out, you've lost track of what it was that you put in there. So imagine once part of your program, you're filling up your array with all kinds of things. 0 gets a string, 1 gets a double, 4 gets an integer, and then later on you pull something out. You pull something out of position 5. And what you get back, you know is a reference to some kind of an object, but you don't know more specifically whether it's an integer, a double, or a string. And so you can't call methods that assume it's a particular type unless you typecast it first. We put the type L in the class definition. Well, what we would like to do is here on line 7, we'd like to say that this array is all of type L. But we're running into this problem that you can't have an array of generic type. And so we're having to do this business with the objects because the language doesn't support arrays of generic types. And so what we're saying is it's going to be an array of object types. And the way that we're sure when we take something out of that array, that when we typecast it to L, the way that we know that it's going to be okay is because the only thing that we're allowing to be put in there is through our add method. And we'll make that clear by making this private. So only we have the ability, only us as the implementers of this class have access to that array. And so even though the language says that it contains objects, we're enforcing the fact that the only thing that we're going to put into it are things of type L. So the language doesn't give us any support for making sure that the things that are in there are L, but we're doing the housekeeping of making sure that the things that we put in there are L. So when we typecast it, we know that it's going to be okay because we're only allowing things of type L to be put in. Okay, so there's I changed one of the methods in the interface between yesterday and today, which is I added a set method. So we're going to need to add that to our implementation here, a set method for the class, not for the iterator. So I'm just going to implement that here, and I'm going to remove something or I will write a set method where we pick a position and we put the new contents in as the second parameter. We walk down to the position where we care about, and we're going to first take out the existing contents, and then we'll say contents sub where equals the new contents. And then we don't need to do any shifting because we are just replacing it. We don't need to change the size. Okay. So if everything worked okay, then we should be able to pass our tests. we already saw that we had tests for our array list and that for our linked list, and that worked okay. So let's just take a look at what our tests look like for our array list. So I wrote one down here for set, which is in between class. So here's one where we implement an array list of type string. We check to make sure that if we try and set something at position -1, that throws an exception. And if we try and set something at position 0 before anything's in there, it throws an exception. Then we add something to position 0. Then we add something to position 0. And then we check its size. And then we go through and we reset every position in the array to the string reset and make sure that that actually took. And then we check to make sure that we can't access something past the end of the array. So if we just run that one by itself, I hope it's going to work okay because we just implemented the code for the first time. How's it going to go? Boop. And great, so it passed the test, and we checked all of the set methods. So that's a good starting point. So now let's run all the tests that we have in place. And yeah, we passed them. So if we then go and look at our implementations, we should see the code coverage green in most of the locations. And so what do we see here? Well, you can see that we didn't add a test for the add method that tries to add something with an index of 0 and validates that it actually throws an exception. So there, we could write another test to make sure that this is green by making sure we try and do these degenerate cases. Okay, so what did we do? We just changed our implementation of array list so that it takes generics. And we did that by changing the method header so that it has generics listed in the top of the class, not the method header, the class header. And then we used that class consistently throughout the methods to make sure that when we wanted to add something to our array or return something from our array, rather than referencing string, we referenced L in this case in particular. Array list was a little bit, well, they both had their own little things that were tricky. So the thing that was tricky about the linked list was the list iterator typecast, or generic. The thing that was tricky about array list is implementing it with objects. But we managed to get it done, so that's good. And so now what I'm going to do is I'm going to show you how to fix our queue type. And then what we'll do is we'll take a break, and I'll have you guys do the same work that I'm doing with the queue type, and you guys are going to do it with the stack type. Okay? So let's take a look at the queue type. And the queue is in there as well. Remember, we built our queue on top of the linked list. And so if I look at my array list queue, it's pretty straightforward. All I did was wrap an array list, and then when I had the add and remove methods in my queue, I forwarded them on to the array list that I was keeping track of internally. So what do I want to do? Well, first of all, I want to change this so I'm not keeping track of string. So I'm going to say, well, what is the type that I'm going to include? I'm going to use T for type. And I'm going to say, okay, the internal array list is going to hold the same thing that my queue holds. So that's going to be of type T. And when I create it, I need to make sure that my type matches, because remember, array list bracket T is the whole type. Without the brackets, it's not a complete type. And down here, when I decide to add something, instead of adding a string, I'm going to add a T. And down here, when I remove something, instead of removing something, I'm going to remove a T. Or instead of returning a string, I'm going to return a T. And then I have a fair number of bugs. Let's see what Eclipse is going to complain about. Okay, so I need to change my interface as well so that it is also generic. So say that what the interface says is going to match what my implementation does. So my queue, the interface that I'm going to be creating is going to be of type T. And everything goes cleanly. That should break my test now because I've now created a new class, which is generic. And so when I want to create a new class, now I'm not the implementer anymore. Now I'm the application programmer. So now when I actually use this thing, I have to be clear. What is the type that my queue is going to hold? Well, based on my test here, I'm assuming that my queue is going to hold strings. So I'm going to go ahead and declare that my queue is going to hold strings, and then the interface that I'm going to be working with is going to be strings as well. And so now if I run my test for Q, we pass it. Yay. All right, so here's the stack type. We've got two different implementations, an array list and a linked list. And I'm going to go ahead and change the interface so you don't have to do that. I'm going to make the interface assume that there's some generic type T that it's accepting. When we put something on the stack, we're going to put things on of type T. And when we take things off, the things that we're going to return are going to be of type T. And when we ask for the size, we're still going to get an integer back. Because what we're doing is we're counting references to objects. We're not doing anything related to the nature of that data. All right, so your task then is to fix the stack class. So there are 4 files there that need to be addressed. The implementation of a stack with an array list, the implementation of the stack with the linked list, and then the tests that are associated with them. I'm going to break the Saros link here so that you guys can edit the files in place and not run all over each other. And then we'll come back together and we'll take a look at what you created. I think. What will we do? Maybe we'll just take a break and let you guys do it, and then not sure exactly how. Maybe I won't. We'll just see what happens. Play by ear. Okay, so it is 10:54 right now. It was pretty fast for me to do this. How comfortable are you guys with duplicating with what I did? How much time should we give? Thinking like 10 or 15 minutes. Okay, so let's come back at 11:10, having fixed the stack so that both implementations of the stack support putting any kind of references in, not just strings. Questions online? Okay, so back at 11:10, having implemented the stack type. Great. We are taking a little bit more time than expected, so we're going to work through some of the details, and we'll be back. Okay, we're coming back online. We, not totally surprising, but that was a little bit challenging. We had a couple glitches that happened because people didn't start with the appropriately generic version of my stack. And so when we tried to do my array list stack, it didn't. Since that was difficult enough, let me go ahead and do the response, do the fix real quick so that people at home can see what the change is, and you can slow down the video if necessary in order to follow along. So the first thing that I've got is that I've got my stack has a generic version with the T's here. And then what I'm going to do is I'm going to go to my array list stack, and I'm going to turn it into a generic version by using some letter that I want here. I'm going to use U just to demonstrate that it can be different. And this is working both as an implementer and a user, because I'm going to implement something of my stack U type. And so my array list in my stack, the one that I'm going to wrap, that I'm going to use as my stack, is going to keep the same things in it that I'm being asked to keep in it by whoever's using me as an application program. And then instead of pushing strings on, I'm going to be pushing U's. And instead of returning strings back, I'm going to be returning U's as well. And then what I'm returning for size is still going to be an integer. That still makes sense. When I now want to test this work, I've just made a class that is going to be a generic version of my stack that's backed by an array list. When I want to test that, I need to come in here, and I now need to say specifically, in my test, I want to store string. I'm actually going to use this class to store string. So I'm going to include in the name of my type, not just my stack, but also what it is that I'm storing. So down here, when I do push and I push a string, it's going to work okay. And if I run this as code coverage, run this as JUnit test, that should run. Yay. And okay, so now, if we want to do the same thing with the linked list, well, we're going to do the same thing. We're going to say that it's implementing the myStack interface, which means that all of the methods down here have to take a generic type, and they have to return a generic type as well. So that's required by the myStack interface. But what I'm using to back it is now going to be using a generic type as well. So I need to say the thing that I'm wrapping, the thing that I'm storing as my implementation detail, the private linked list, also has to store the same types as what I'm being asked to store here. And then I just wrap my add and remove method with a call to push and pop so that the interface looks like a stack. Save that, and then take a look at my test. And in my test, again, because we're actually using it now, we have to specifically say what is it that we are trying to test. And Boaz is getting an error online. Let me run this test, and I'll see if I can see what he's got. My JUnit test, and get pretty good coverage. All right, question online is, got an error that said the type array list is not generic. It cannot be parameterized with arguments T. All right, so Boaz, make sure that in the top here, when you're doing import, make sure you're not importing the Java version of array list. Make sure you're importing the version of array list that we created. So for example, in my stack, here's array list. What you want to see is you want to see a line like this. You don't want to see a line that says something like Java language.array. See if that's what you got. Okay. Moving forward from there, I want to work through a couple more examples because I think that what we need is a little bit more exposure to using and writing these things. Let me broaden our horizon just a little bit. So far, we've talked about these classes that can use one particular generic type across the entire class. You don't have to have a generic type that is used across the entire class. You can use a generic type that's just consistent within one particular method as well. So if you want to declare a method that takes a generic type, you can do that like this. So on the top, what we've got there is we've got an implementation of a generic class. And so when we had a generic class, we had to declare this thing of type L. It had to match something that we were implemented. That's fine. But if we want to do something for just a method, and we just want a generic type for our method, what we do is we add the brackets right here. So now we've got a bunch of stuff in our bracket, in our method name. We have a visibility indicator, public, private, protected, default. We have whether or not it's a static method. This happens to be a static method. Now this, putting the T in angle brackets here says, well, now you can use a generic type within the definition of this method. Our method returns nothing, it returns void. Our method is called fill. It takes two parameters. The first parameter is called myList, and it is of type ourList angle bracket T. So here I'm using the generic parameter T. So what I'm saying is this fill method can work with any type. We're just going to let the compiler fill in T. But whatever our list is, it is going to be some list of type T. The second parameter has to be of the same type. It also has to be of type T. And the reason why is because what this method does is it's going to fill up this array list, this list that we created with something of value type. And so we do that with a for loop. We go from 0 to the size of our list, and we set position I equal to the value that we got. Now this would fail if we had said value was of type string, because you can't put strings in something that in myList. myList has to have things that are of type T. We could have written this specifically. We could have said that our list contains strings and value was of strings, but then fill would only work for one kind of code in which we have a list of strings and a type of string. But this could really work for anything. We can parameterize this type with any type we want by making it generic along the way. So this is exactly the same as a method that would be present in a generic class, except that what we've done is we've added this T right here to say that this generic type T is only relevant in this one particular case, the case where we are using that generic type in this. All right, so what I want to do now is I want you to try this example. In the code base that I shared, there is a class called example1, and you'll see that exact method that I just had on the slide implemented. And so down in the main method, there's 4 comments that can be replaced by some number of lines of code. So what I want you to do is I want you to first declare a variable that's going to hold a reference to an object of type ourList. And this is an example where you're using ourList, so you're going to have to pick what's going to be stored in it. Then I want you to point the variable to that new list object, or assign it to that reference. Then add 5 elements to the list that you just made, and then call the fill method that's listed above to replace those 5 elements with some new value along the way. So this is going to be an opportunity to flex your muscle memory, to work a little bit with this concept of generics and try and understand how this is all working together. Now this is slightly different than what we just did, because this is an example of a method that's a generic type. Because if you look at the declaration of this class, in the declaration of the class, there's no generic type. It's just a generic type that's scoped to the fill method. Okay, but we can still do that. So let's take, given how the last one went, why don't we take about 10 minutes to try and do this one? So we'll come back at 11:40. And let's see, did you guys get a clean version of this when I shared the code? You see that? Okay. All right, I think, Boaz, you probably have a good version. All right, so we'll take 10 minutes, come back at 11:40, and try and fix this, or try and implement this task. Okay, coming back in, let's go ahead and work through this example live and close out my other work here. And we'll drop into the examples. We'll look at example 1. And what we wanted to do here is first declare a variable that's going to hold a reference to an object of type OurList. So let me break that down. We need a variable, so we'll pick a name, and I'm going to call it X for our variable name. And it's going to hold a reference to an object of type OurList. So type is going to be OurList. And since we've made that generic now, I have to say, well, what is OurList going to contain? It's going to hold strings for this test. And I'm going to call that variable X. So what I've done right there is I've declared a variable that's going to hold a reference to an object of type OurList. Strictly speaking, that's the right thing. Now what I'm going to do is I'm going to point that variable to a new list object. So I'm going to say X is now assigned, or it's going to be a reference to, a new OurList object. But this isn't going to work because OurList isn't an implementation. OurList is just a behavior described as an interface. And OurList doesn't actually implement that behavior, but I could choose to either choose to use this reference to point to an implementation of ArrayList or linked list, both of which implement the OurList interface. So both ArrayList and linked list have the same behavior that's described in the OurList interface, and they actually implement it in a particular way. So I'm going to choose linked list. And this linked list, I'm going to make sure it's the one that I declared because we're working within our code, not within Java standard. And we've implemented it as a generic type. So X is going to get a reference to a new linked list that holds strings. Now I'm going to add 5 elements to that list. So X has the linked list has a method called add, and we have to say which position we want to put it in. And the way ours works is that it shifts everything over to the right, but this is the first element, so it's going to be the first one. So I'm going to add 5 more elements, and again, the way that our list works is that when you add something to your list, it moves everything over 1. So this is going to end up adding in reverse order. So I'm going to add a bunch of coffees, if I can come up with coffee-producing regions. Asian, Ethiopian, Kenyan, Kona coffee, Brazilian. All right, so there I added a bunch of methods, and now what I want to do is I want to replace them all by using this fill method above. Well, fill is a generic method. It takes a generic type T. Now, that's how it's implemented. But when we call it, we have to call it with specific already filled out types. So I'm going to just call it with fill. X is already implemented on our list of type T. And then I'm going to replace it with a coffee type. Give me another coffee. Where we got thinking around the world, global. What's that? Guatemalan. Nice. What do they do with spelling? Really? How do you spell Guatemalan?
Okay, I found this on the web.
Oh,
how do you spell?
Where is Guatemala? No, let's see. I just need I just need a question that contains Guatemala. What color is Guatemalan coffee?
Okay, I found this on the web for what color is Guatemala.
I'm right. Okay, so what did I just do? I called the fill method. I passed it a parameter. The first parameter was of our list string. So what the compiler does is it takes this T and it replaces it with a string. And so therefore, this T must also be a string. And fortunately, what I asked it to fill it with was a string, so it worked out okay. And so now if I look to see what is in a particular position in my list, I can do x.get, say, position 3, and see what ends up getting printed out. If the world is as it should be, it should print out the word Guatemalan. And we see as much. Okay, so now here's what I want you to try. What happens if you try and pass the wrong type into the second parameter? So try calling fill if you used a string as what was being stored in your our list type, try passing an integer to value. See what happens. Okay. Did all of you get something like that? So what happens is, because we have this generic type, it's in a method, right? It's not a class, it's just a generic type in the method in fill. The compiler is able to say, well, I don't know what type you're going to be using in advance. I know that it's going to be T, but I do know that it's got to be consistent. Whatever you're keeping in our list has to be the same thing that you're going to pass into the fill method. So if I had tried, and I can get the same behavior, if I try and pass in a 3 here, there's type checking that's present, and I can get this error that says, hey, something's going wrong. You said that what you're going to take in this method is going to be a list of type T and something of type T, and I don't know what it's going to be, but I do know it has to match. And you're calling it, and it doesn't match. So I'm not going to let that compile, because that would go against some expectation that the programmer had, which might introduce some sort of bug into your code. So this is the kind of protection that you get. But we didn't have to write a whole bunch of different versions of fill. We didn't have to write a version of fill that looked like this. And do that for every single different type. We only had to write it with our generic type T, and it will work for anything that we decide to write in the future. Down here, switch this back. Down here, we're using very specific types. We're using this class. So this is an interface. So we know whatever we're going to store in X is going to be a reference to something that implements our list interface. Here we're saying, no, I'm actually going to create a list that contains strings. I'm actually about to use it. This isn't a systems programmer. This is an application programmer. I'm using this class to do work. So it's going to contain strings, and now I'm going to put strings in. All right, let's do another one. Let's try this example here. This is a little bit more involved. So what I'm going to have you do is we'll take 10 minutes to implement this. So example 2 is in the code that I shared with you, but there's no code in there. So I'd like you to type this out and see what happens as a result. And we'll see if we can figure out why we get the result that we get. Okay, so 10 minutes to type this one out and see what we get as an outcome. Yeah, we can try that. Sure. Okay, coming back in. So this is an interesting example because a couple things are happening here. For starters, what we're doing is we actually appear to be doing exactly what I said you couldn't do. We're creating an array in the fill method of a generic type. And then down in the main class, we're actually calling that fill method as well. But this ends up causing a runtime error. And unfortunately, unlike the example when we used proper array list generic syntax, the compiler didn't catch the fill A42 as being an error. If this had been a perfect world, when we tried to call fill A with 42, the compiler shouldn't have allowed that because we shouldn't be able to put 42 into an array of strings. But here's what's happening. Unfortunately, the call compiles because when we make that fill call down in the main method there, indicate what I'm talking about. When we make this fill call here, the compiler attempts to resolve the types for T here and the types for T here. And when it looks at what we've passed in here, it says, oh, this is an array of type string, and this is an integer. So in order to get this to work, I must go to a common parent of both string and integer. And so I'm going to replace T with the object, the type object. And so the choice ends up being justified because the string array is convertible to an object array, and 42 becomes an integer 42, which is convertible to an object. So T becomes object and T becomes object. But when the program actually comes to this point and tries to store 42 into position I, you get a runtime error here because you can't store a 42 into an array that's actually holding string. This is a really nuanced and complicated example here. But the way to avoid falling into this trap is to don't mix generics and arrays, or more generally, don't mix generics and primitive types, of which array is one particular version. Never use arrays and primitive types with generics. And so this moment right here, this should have been the warning to you as a programmer that you're mixing a generic type and an array. And this is something that's going wrong. Right there. And then as a result, this passes. But if you recall, in our previous example here, or rather when I implemented it, that same code wouldn't have passed here when I tried to put 42 in. Right? So if I try and fill it with 42, because I'm doing the proper thing and using generics with object references, it doesn't end up getting compiled. And as a result, I don't end up with a runtime. Okay, so the answer was that was bad. So let's do one last example together. And what I would like us to do is to implement this code and try and work through what do we have to do in order to get this to work. So there's a placeholder in the code for this algorithm class, but it needs a public, it needs this method described. So let's just, before we dig into it, let's just try and say what it is that this code is supposed to be doing. It's a class called algorithm, and it's a method called max. And I'm not sure if we've talked about the syntax for the question mark. Have we done that in this class? Okay, that's a fast if-then statement. So that's equivalent to saying if x is greater than y, return x. If x is not greater than y, then return y. So basically what this is trying to do is it's trying to write a method that returns x if it's greater than y, or y otherwise. But it's trying to do it in this generic way that doesn't commit to a particular type beforehand. All right? So let's take a second and type this into Eclipse and see if we can work through what we have to do in order to make this intention to actually work out. Okay, so the short answer is no. It doesn't. And is this the error that you were getting? You're getting t cannot be resolved to type. Okay, so the first thing that I'm going to do is I'm going to expand that question mark syntax. I don't want to confuse this example with that shorthand notation. This is what that question mark colon syntax actually does. It's just shorthand for what I typed. If x is greater than y, return x, otherwise return y. All right, so the first problem we've got is that Eclipse doesn't understand the type t. So why is that? Yeah, we haven't said what t is. Right now, the way that we've written it is we've said, well, this function max is going to return something of type t, and it takes two parameters which are of type t, but we haven't imported a class called t, and we haven't declared that this class has a generic type of t. We also haven't declared that this method has a generic type of t. So t is just like some like circle or rectangle or linked list or array list. It's just this type that has no anchoring in an actual implementation. So if we want this to work, the first thing that we need to do is we need to add some kind of assuming that what we intended here was for that to be a generic, which seems consistent with what we're trying to do. We need to declare that there is a generic type that's available to us at some point. So we can either do that as part of the method, or we can do that as part of the class. So if we want to do it as part of the method, we would have to add bracket t here to say that t is something that we can use generically. That's going to get a little bit confusing, I think. So I'm going to go ahead. Well, I don't know. What do you want to do? Do you want to do it as part of the method or part of the class? Let's do it as part of the class. It's going to be slightly less. All right, so we've declared that within this class, if anyone that's going to use our class has to fill out what t is going to be. But in the implementation of our class algorithm, we're going to work with t as if it's a generic parameter. So now you can see that the error that was previously on line 5 has gone away. You've seen the same thing in your code? It's moved down. And now we have this new problem. This new problem is on line 7. The operator greater than is undefined for the argument types t and t. So that means that, well, it's all well and good that you want to check whether something x is greater than y, but I'm not even sure, this is Eclipse talking, I need a different voice for Eclipse. I'm not even sure that t and t can have a greater than. So it's not even clear that whatever class that you're going to end up implementing algorithm with, whatever you're going to substitute in when you're using it, those things can be compared with a greater than, right? Like what if you pass in like a class called identity, and you can't do identity greater than another identity. Now you could call a method on it that has the same effect, and so maybe that's what we should do. Let's do that instead. We already have a method that we're familiar with that does comparisons like this. Do you remember what that one's called? Equals would check if it's equals specifically, and then there was another one that was like it. Compare to, exactly. So let's go ahead and say if x.compare to y is less than 0, then x should come greater than 0 because we're doing max. Then x should come afterwards. Well, that's a little bit better. But now we've pushed the error down a little bit more. So now the error that we're getting is that the method compare to is undefined for the type t. Oh, well, that kind of makes sense. Because what if you're passing in some class, or what if you're using some class when someone uses your algorithm, and what if t doesn't have a compare to method? Like in the pair methods that we implement, or the pair class that we implemented earlier in the sequence on generics, that doesn't have a compare to. So what can we do to make sure that the class that gets passed in has this method available to us? Is there anything that we can do to make sure that we have that method available to us on the variable x? And what we can do is, you remember we were talking about how generics allow any class to be substituted in for that type. So we can put anything in for T. And then at the other end of the spectrum, we could have written algorithms so it only works with one specific class. This is an example of a position halfway in between, where we want to use a generic, but not any type. We want a very specific range of types that we're going to send in. So what we're going to do is we're going to say that T can't be anything, but it has to extend the comparable interface. And so comparable is like our list. It's an interface. And what happens if we say comparable bracket T is that's an interface that says that you can use any type you want to as long as it implements compare to. And not only does it implement compare to, but it has to implement compare to in such a way that the parameter that it takes is also of type T. So you can see down here when we call compare to, this is of type T, and then the variable that it passes in of type. So now if we wanted to use this, if we wanted to use this max method, we can do it, but we can't do it with anything. So if we want to throw in here void, public void main string, public static void main. All right, we want to now actually use that max function. Well, we would have to do it with something. So we could say string max equals the max of hello and world. In order to do that, I'm going to come up here, make this static, and hope that doesn't. So first I'm going to create something of type algorithm, string. All right, so I'm going to create an object of type algorithm. Then I'm going to ask algorithm to calculate the max of hello and world. So now this is okay, because string implements compare to. String has a compare to method, so this works out fine. When I first created my algorithm object here, I put in a type here that the compiler will substitute for T. But the compiler is only going to allow me to put things in this position if it extends comparable T, if it implements compare to. So if I tried something else, like I tried algorithm, I don't know, something that doesn't implement compare to. Maybe what have we used? Clicker. Let's see if we can, no, I don't have anything handy. Well, let's see. Our array list doesn't. Let me just make a new class. It doesn't. So here's a class. It doesn't do anything at all. But if I try and create an algorithm object here, this is going to fail because dummy doesn't, well, let's see, why is it failing? Because dummy doesn't implement comparable, that's for sure. Why am I not getting that? There we go, great. So it says dummy is not a valid substitute for the bounded parameter T extends comparable. So I can't do that. I'm not allowed to pass in a type that doesn't implement comparable. If I go here and I say, yeah, it's going to implement comparable to dummy, well, now it says, well, if you're going to implement comparable to dummy, you better implement that. You need to actually do compare to. So, okay, no matter what, I'm going to always return 0. That's not a very helpful version of a compare to method, but now it compiles okay. Now it's okay to do that because in this code, when I call compare to, that will be a method to actually call. If I get rid of the implementation of compare to, again, it goes back to being not. So what we looked at there is we looked at how in order for this to compile correctly, we had to make some changes. We had to make sure that T was a known type. And we did that by adding that to the comparable here. And then we had to make sure that we used compare to in order to make that work. If we had instead not wanted to declare this type in the class, we could have put it as a method generic and said T extends comparable T. And that would. But you can see why I put it in the class header maybe, because that's a lot less confusing than what I just did. Maybe. All right. So will the following code compile? No. We had to do a bunch of work in order to make that achieve what it was that we wanted to achieve. What do we need to do to fix it? We need to declare T. We need to not use greater than. We need to use compare to. When we wanted to use compare to, we had to restrict the types of classes that T could be, and they had to be ones that implemented comparable. That's what we had to do. All right, so that brings us to the end of our discussion of generics. For your homework, you're going to be implementing a pair, a triple, and a quad that is genericized. High level, what generics do is they enable types like classes and interfaces to be parameterized by another type, the language of types. The inputs to generics are types, so the things that you fill in that type are other types, and the output of generics are new atomic types. For example, array list bracket string is a brand new type, the whole thing. It's composed. They're like parameters and methods, but they're about types and not data and not values, and so in that sense, they're metadata. And we do this because it enables us to reuse the same code with different kinds of inputs. We can write that fill method one time, regardless of what kind of list or data we're putting into it. We can write an array list one time without worrying about what's going to be stored in it, but still getting the benefits of compile time checking. Benefits are that we write less code. We only have to write code one time. We get to reuse it. We have less bugs as a result. That enables programmers to implement generic algorithms that are focused on the manipulation of the data, but not particularly what the data is necessarily. Gives us stronger type checks at compile time, and therefore we have more errors found at compile time through static type checking. That's it in a nutshell. Any last minute questions? Hopes for the future? Okay. So you'll have two chances to exercise the stuff that we've done today in class. One is in the quiz that's due on Friday, and one is in the programming assignment. And I think that's it for today. So thank you for your attention. Have a good lunch. Stay dry. Those of us online, thank you for your attention. Appreciate your participation. And we will see you soon.